Hi everyone, this is Dr. T. Siva Nageswara Rao, working as Assistant Professor of Mathematics in the Department of Mathematics and Management Sciences. Now I am going to explain unit number 4, named as Functions in Several Variables, in the subject Matrices and Advanced Calculus. The subject is meant for first semester for all BTech branches, all the branches in BTech. The contents are definition of limit, continuity, partial differentiation, in which we will study about first order partial derivatives, second order partial derivatives. Together with this, we will talk about chain rule. It contains total derivative. Later, we will see about Euler's theorem for a homogeneous functions. Next topic is Jacobian, in which the application part is based on Jacobian. We will discuss about functional dependency. Later we will see about Taylor's theorem of the given function involving two variables. And final topic is maxima and minima of the given function involving two variables, in which the special method called Lagrange's method of undetermined multipliers. Now I am going to explain about what is the concept of limit in view of a function involving two variables. In your lower classes, you people are already familiar with the concept of limit for a given function involving single variable, like limit as x tends to a, f of x. In view of this limit, if a function involving only single variable, we will see only two directions. One is limit as x tends to a plus f of x. We will call it as right hand limit. Similarly, limit as x tends to a minus f of x. This is called left hand limit. If both are same, then only we can say the limit is exists. So the concept of limit for a given function, if it is involving two variables, then it is completely different from the concept of limit if a function involving single variable. Now we will see what is the concept of limit if a function involving two variables. Let f of x comma y be a function defined on a domain capital D subset of R square. That means in two-dimensional plane. Let a comma b be any point of capital D. Then we say the limit as x comma y tends to a comma b, the value of function f of x comma y will goes to some finite real value capital L. The L should be finite. Then only we can say the limit is exists. Otherwise the limit does not exist. Here what are the key points? The value of the function must get arbitrarily close to L regardless of the path taken towards the point a comma b. What does it means? It means in view of two-dimensional plane, if you are taking the point a comma b, assume that somewhere you are at here x comma y. Our aim is to reach from the point x comma y to a comma b in different paths, like this, in different paths. Whatever the path you are choosing, like if you are taking n number of paths, let us take one path from it, try to find out the limit as x tends to a, y tends to b, f of x comma y will goes to L1. So for each and every path, you will get a different limits, like say L1 comma L2 comma so on comma Ln for n different paths. If all ln's are same, then only we can say limit of the given function f of x comma y will exist. Next one, the limit value is not same along the different paths. Means what? For one path the limit is L1, for another path the limit is L2 between 2 points x comma y to a comma b. Then we can say directly L1 is not equal to L2. If L1 is not equal to L2, we can say directly the limit of the given function does not exist. So the concept of limit is completely different from a function involving single variable to a function involving two or more variables. In view of single variable, we have only two directions. One is right direction and other one is left direction. But coming to function involving two or more variables, the procedure is completely different. Now we will see a small examples related to a function involving two variables, the concept of limit. Concept of limit if a function involving two variables. Now take this example, limit as x comma y tends to 0 comma 0. Now here say, first I will fix x is equal to 0. I will vary y is equal to 0. That means x is equal to 0 fixed, means 0 comma y. Again y will vary, y tends to 0. This is one path. Means what? This is 0 comma 0. This is the point x comma y. First I am taking x is equal to 0. Then this will move to 0 comma y. Now I am going to vary y tends to 0. This is one path. This is one path. Now what is another path? If I am taking another path, this is the point x comma y. This is the point 0 comma 0. First I will fix y is equal to 0. Then this point will move to x comma 0. Later it will move towards 0. So this is another path. Now we will see what is the limit in two directions, that is on two paths. First if I am taking this is put y is equal to 0 and later x tends to 0. You will get 0. And this one, fix x value and y tends to 0. This is second path. This is another path. Between these two, there is one more path, y is equal to x. There is a chance. Why? Because the equation y is equal to x passing through the origin. And next one, this is one more path, y is equal to mx. Y is equal to mx, family of straight lines passing through the origin. If you are taking any of the paths, four paths, the limit is always 0. The limit is always 0. So if you are taking any path between, any path passing through the 0 comma 0, always we are getting the limit is 0. In such cases only we can say the limit of the given function as 0. This is one of the example. The limit is exists if you are taking n different paths. Not only y is equal to mx, we can take y is equal to mx square also. Next example, limit does not exist. Now see here, limit as x tends to 0, y tends to 0. Fix x is equal to 0. Then y tends to 0. Fix x equal to 0, substitute here. This is 0 and this one is 0. You will have only y by y square. 0 multiplied with this y, you will get numerator as 0. As y tends to 0, you will get 0 for this path. Now I am going to fix y is equal to 0. If y is equal to 0, then numerator becomes 0 and denominator is 0 by x square. Limit as x tends to 0, it is also goes to 0. On both the paths, the limit is 0. It doesn't mean that limit is exists. We need to check for possible paths. Here I am taking one of the path is y is equal to x. One of the path is y is equal to x. If I am taking y is equal to x, then limit as x tends to 0, x square divided by 2x square. It goes to 1 by 2. I will take one more path, y is equal to minus x here. If I am taking y is equal to minus x, then limit as x tends to 0, it goes to minus x square by 2x square. Hence answer is minus 1 by 2. Here we are finding the limit corresponding to the given function f of x comma y in 4 different paths. One path is fix x equal to 0, y will vary. Another path is fix y equal to 0, x will vary. Third path is along the straight line y is equal to x. Fourth path is along the line y is equal to x. If you are observing the limits along all these 4 different paths, the values are 0, 0, 1 by 2, minus 1 by 2. Here the observation is along the paths the limit is varies. Hence we can say the limit does not exist. Therefore different paths gives different limits. So the limit does not exist for the given function. So in view of limits, for a function involving 2 variables, you need to search for alternative paths. With respect to 1 or 2 paths, please don't decide the limit is exists. This is what you need to remember. So these are the few model questions, that is worksheet problems you need to practice. Practice all these problems together with this already provided answers also. Please practice these worksheet problems. Now I am going to discuss about a definition of continuity of a function involving 2 variables. In view of continuity, what are the steps you need to take care? Take the given function, that is let f of x comma y be a function involving 2 variables. When do you say a function f of x comma y is continuous at a point a comma b? First one, in the function definition, this value should be exists. Together with this, if this limit is exists and both are equal, then only we can say the function is continuous at a given point a comma b. Here if you are observing, this is also one of the condition in view of discussing continuity. So this is looks like limit of a given function involving 2 variables. Just now I discussed about it. Don't depend on one path for deciding the limit. You need to search for different paths. If you found the limit is varying, we can say confidently the limit does not exist. So from this formula or from this condition, we can say if you want to talk about continuity, limit is necessary. Without limit, it is not possible to talk about continuity. So your focus should be mainly on limit. Please keep it in your mind. Now I will discuss about examples. First one, check whether f of x comma y is equal to x square plus y square is continuous at 0 comma 0 or not. Previously, I explained about what are the conditions you need to satisfy for the continuity. So, first point is, we need to know what is the function value at a given point. What is the function value at a given point? F of 0 comma 0. Clearly f of x comma y is x square plus y square. Answer is 0. So, we know what is function value at a given point. Limit as x tends to 0, y tends to 0. What is x square plus y square? 0. If you are taking any of the path as your wish. Let us take y is equal to mx square. Let us take y is equal to mx square. Then what you will get? Limit as y is equal to mx square means again it goes to x tends to 0. X square mx square equal to limit as x tends to 0. Take out x square as common. 1 plus m. It goes to 0. Like y is equal to x, y is equal to x square, etc. etc. That means what? Here the limit does not depending upon m. There is no effect of m. There is no effect of m on the limit. Hence we can say the limit is exists and which is equal to the function value. Hence the conditions associated with continuity definition is satisfied. Therefore we can say the function is continuous at 0 comma 0. Next example, I will explain about discontinuity of a function if it is involving two variables. Now here what is the given function? F of x comma y is equal to xy divided by x square plus y square, comma x comma y is not equal to 0. F of x comma y value at 0 comma 0 it is already given. So first condition in continuity equation is satisfied. Now coming to second condition, we need to verify for a limit. Now if you are taking path y is equal to x, y is equal to x, what is the limit of the given function? The limit of the given function will goes to 1 by 2. If you are taking another path, like take y is equal to mx, without loss of generality, I will take m is equal to 1, you will get y is equal to x path. M is equal to minus 1, you will get y is equal to minus x path. I am going to check the concept of limit on both the paths. If x comma y goes to 0 comma 0. In two different paths, I am getting two limits. Hence, limit is varies with respect to m. So limit does not exist. I already told for discussing about continuity, limit is necessary. Unfortunately here, limit does not exist. We can say the function is not continuous at 0 comma 0. So, I given two examples. When do you say the function is said to be continuous? When do you say the function is discontinuous? Now, these are the worksheet problems. Please practice. I also given answers for all these worksheet problems. This one, last one is f of x comma y continuous at 0 comma 0? Answer is yes, it is continuous. It is continuous. Okay, right. Next. Now I will discuss about partial differentiation. In view of partial differentiation, I will discuss first order partial derivatives, second order partial derivatives. Now I am going to define partial differentiation. Let z is equal to f of x comma y be any function involving two very independent variables x comma y. The partial derivative of z with respect to x denoted by dou z by dou x, dou z by dou x, and is calculated by treating y is constant. It means whenever you are applying partial derivative with respect to x, you need to treat other variable as constant. So we will treat y as constant. In the same way, if you are applying the partial derivative to z with respect to y, we will treat the other variable x as constant. Here, the partial derivatives dou z by dou x and dou z by dou y are said to be first order partial derivatives. In the same way, we can able to find second order partial derivatives also. Let us take same function z is equal to f of x comma y. Previously I written in place of f with z. Here directly I am taking in place of z with f. That is dou square f by dou x square. Means first dou f by dou x I will calculate. Again for this I will apply one more time partial derivative to it. Then you will get dou square f by dou x square. Dou square f by dou x square. Similarly, with respect to x, dou square f by dou x square. With respect to y, 2 times partial derivative, dou square f by dou y. Now, mixed partial derivatives. First, I will take dou f by dou x. For it, I will apply one more time partial derivative with respect to y. Then it is denoted by dou square f by dou y dou x. Vice versa, reverse order. First, I will apply partial derivative with respect to y. Next, I will apply partial derivative with respect to x. When do you say these two partial derivatives are same? Condition is the function f of x comma y is continuously differentiable. Then only these two partial derivatives are said to be equal. This is also called symmetric property of partial differentiation. So this is about first order and second order partial derivatives. Now I will explain one example how to find first order and second order partial derivatives for a given function if it is involving two variables. So I will take z is equal to x square y plus sine of xy. Now first I will apply dou z by dou x first order partial derivatives, dou z by dou x. I already told whenever you are applying partial derivative with respect to x, treat other variable as constant. Therefore y is constant. The derivative of x square is 2x plus, it is like sine x, assume sine x. What is the derivative of sine x? Cos x. So cos of xy. Again I will apply derivative to an expression which is inside trigonometric function sine. So partial derivative of xy with respect to x, it becomes y. This is the value of dou z by dou x. Similarly, dou z by dou y. This is equal to x square is constant. The partial derivative of y with respect to y is 1 plus cos of xy. With respect to y, we are taking x as constant multiplied with a x. So these two are first order partial derivatives. Next I am going to find second order partial derivatives, that is dou square z by dou x square. Dou square z by dou x square is one more time partial derivative to dou z by dou x with respect to x. So it becomes 2y plus y into minus sine of xy multiplied with y. So y multiplied with y becomes y square. This is dou square z by dou x square. Now I will calculate dou square z by dou y square. Dou square z by dou y square. Partial derivative to dou z by dou y with respect to y. This is equal to x square derivative 0, 0 plus its cos x y derivative sin xy partial derivative with respect to y. Again, anyway, we have x. One more x you will get, x multiplied with x, x square. This is dou square z by dou y square. Now, I am going to explain dou square z by dou x dou y. This can be written as dou by dou x of dou z by dou y. So, for dou z by dou y value, I am going to explain partial derivative with respect to x. You will get answer as x square derivative 2x minus sine of xy multiplied with y multiplied with x, that is product of two functions. So I will apply product rule in differentiation, minus this is plus cos of xy. The partial derivative of x with respect to x is 1. Now here I will try one more derivative, that is dou square z by dou y dou x. This is equal to dou by dou y of dou z by dou x. This is equal to dou by dou y of this one. This is dou by dou y of dou z by dou x. So for dou z by dou x, I am going to apply partial derivative with respect to y. Then what you will get here? 2x minus xy into sine xy plus cos xy. If you are observing these two derivatives, then these two derivatives are same. How? Because x square y plus sine xy is continuously differentiable functions. Hence, these two derivatives are always equal. Next one, this is worksheet part 1. Here I given different problems. Here you need to find what are the first order partial derivatives and what are the second order partial derivatives for different problems. Please practice all these problems. Next, I will discuss about chain rule in partial derivatives like total derivative. This is similar to total derivative. Let z is equal to f of x comma y be a function where x is a function involving single variable t, y is a function involving single variable t. If you are observing these two, then I can say the variable z is completely depending upon t only. Therefore, I can able to talk about dz by dt. So, this dz by dt in terms of partial derivatives. Here we are taking the sum of partial derivatives. It is defined as dz by dt is equal to dou f by dou x into dx. Why here we have partial derivative? F is depending upon two independent variables. Means z is depending upon two independent variables. We'll get the partial derivatives. So dou f by dou x into dx by dt, dou f by dou y into dy by dt. If you are taking sum of these two, then only you will get the total derivative of z with respect to t. This is called chain rule of partial derivative in one variable. Now we will see generalization. Z is equal to f of x comma y, where x is a function involving two independent variables, y is also involving two independent variables. In such cases, we will find two partial derivatives. One is z is depending upon s, z is depending upon t. Why? X comma y is depending upon s comma t. By transitive property, z is depending upon s comma t. Z is depending upon more than one independent variable. We will talk about its partial derivatives. So, dou z by dou s and dou z by dou t. So, these are the values of dou z by dou s and these are the value of dou z by dou y. Now, the difference between first one and second one is, here first one, z is depending upon single independent variable t, But before that, z is depending upon two independent variables x comma y. This is chain rule in one variable. Now coming to second one, this is chain rule in more than one variable. Like this we can extend for three variables also. Now we will see one example. Let z is equal to x square plus y square, means z is involving two independent variables in which x is depending upon t and y is depending upon t square. Now my aim is to find dz by dt. What is dz by dt here? Dz by dt can be written as dou z by dou x into dx by dt plus dou z by dou y into dy by dt. Now I will find what is dou z by dou x, dx by dt, dz by dt, dou z by dou y and dy by dt. Substitute these values into this formula, you will get this one. Now here we have x, y, but we need to express the answer in terms of t only. Why? Because z is depending upon t. Obviously the answer in terms of t only. Finally you will get 2t plus 4t cube. This is the total derivative of z. Next example. Let z is equal to log of x square plus y square, where x is equal to r cos theta and y is equal to r sin theta. Calculate dou z by dou r. What is dou z by dou r? Dou z by dou r is equal to dou z by dou x into dou x by dou r plus dou z by dou y into dou y by dou r. So on right hand side we required four values. One is dou z by dou x, dou x by dou r, dou z by dou y, dou y by dou r. So substitute all these values on RHS side, you will get this expression. Here our aim is to express answer in terms of r. So let us substitute in place of x with r cos theta and in place of y with r sin theta. In place of x with r cos theta and in place of y with r sin theta. Then here we will get x multiplied with cos theta. X is r cos theta, r multiplied with cos square theta. Y is r sin theta, y multiplied with sin theta. You will get r sin square theta. Take out r as common, you will get cos square theta plus sin square theta. Cos square theta plus sin square theta is equal to 1. Hence answer is 2r by r square. You will get 2 by r. So these are the worksheet problems. Please go through it. Try to solve all the problems. So till now I discussed about the concept of limit in view of a function involving two variables, continuity of a function involving two variables. For discussing about continuity, limit is necessary. This is what you need to remember. Later I discussed about first order and second order partial derivatives. Previously I discussed about chain rule. In next class I am going to explain Euler's theorem for a function involving two variables. Conditions applied. It is homogeneous function. We will see in next class. Thank you one and all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.